කිව්වේ bipolar transistor එකේ the transistor had been made by forming three region of P and N semiconductors on a single chip of intrinsic semiconductor, right? එතකොට මේකේ මේ අපි intrinsic semiconductor එකට single chip එකකින් තමයි මෙයා කරන්නේ. මෙතන අර P N E N connect කරලා කරන්නේ නැහැ. We are doping some kind of the material and we are taking this transistor, right, in a one single chip, right? Then I told there are two p-n junction in it, and there are only two ways of p and n type semiconductor can be formed in this method. So these are the two semiconductors, two transistors we can obtain. So there should be a p-n junction in both cases. See, one p-n junction, one p-n junction. So one p-n junction and one p-n junction, right? So this is the bipolar transistors, right? Then they are PNP transistors and NPN transistors. They are PNP transistors and NPN transistors. NPN transistors. Right. එතකොට අපි මේකෙදි NPN PNP කියලා දිනනවා. එතකොට මේකේ collector base emitter කියලා දිනනවා. So how can we find out what is the collector and emitter? The base is always same, right? මේකේ different kind එකක් තියෙන මෙයා base identify කරන්න පුළුවන්. base එක identify කරන්න පුළුවන්. But we have to identify what is the collector. When we are considering the doping level and what is the we mean there is a holes, right? Holes වැඩියෙන් තියෙන එක තමයි අපි ගන්න ඔය collector එක කියලා කියන එක. ඊට පස්සේ emitter එක මොකක්ද කියලා එහෙම identify කරගන්න, right? එතකොට අපි මේකෙදි මේ NPN transistor එකත් එහෙමයි. හැබැයි මෙතනදී මේ majority carriers, what are the majority carriers? They are holes. Majority carriers are holes. In this case, majority carriers are electrons. Most of the mobility of the holes and the electrons, there is a mobility in the electrons. That's why we are considering NPN transistor. In every case, we have to consider the NPN transistor, right? Okay, write down. Okay, draw this one. To connect a transistor to a circuit, there are three terminals which are connected to P. N and P region, in brackets, PNP type, PNP region, PNP type, or NP and N region, NP and N region, in NPN type, concerning action of the transistor, the transistor, the region which emit charge carriers, which emit charge carriers, is known as emitter. Is known as emitter. There are emitter කියලා කියන්නේ මෙතනින් charge carriers එළියට emit කරනවා. collector කියලා කියන්නේ charge carriers මෙතනින් ගන්න එක. මෙතන P කියලා කියන්නේ what is the P mean? false charge carriers ගන්නවා. P කියන එකේන මේ මෙතනින් charge carriers එළියට දානවා. එතකොට මෙතනදී electrons එළියට දාන්න බෑ. අපි ඒ reason එකකින් තමයි emitter collector කියලා මේ දෙක change වෙන්නේ. ඒකට මේ emitter එකේ doping level එක වැඩි, collector එකේ doping level එක moderate. Right? And the emitter is known as emitter, and the region where charge carriers and the region where charge carriers are collected is known as collector is known as collector. එතකොට what is the base? Base mean the middle region මේකෙදි මේ middle region එකේදී ගොඩක් වෙලාවට මේක පොඩි එකේ අර දෙකට සාපේක්ෂව මේක ටිකක් පොඩි. ඒක කියන්නේ collector the thin region in between them controls the flow of charge controls the flow of charge carriers is known as the base. Right. Okay. So the semiconductor regions are these are three semiconductor region. So they are this one collecting the charge carriers, and also this is the intermediate stage. So this is the thin layer. So in the JFT junction, that when we are discussing the field effect transistors, that means there is this kind of thing, but there is a gate. මේ වගේ පොඩි gate එකක් තියෙනවා. ඒකේ තියෙන්නේ මෙන්න මේ වගේ දැන් අපි n channel JFT කියලා එහෙම තියෙනවා. එතකොට මෙතන මේ අර මෙතන gate එකක් වගේ තිබුණා ඒක අරනවා වෙනවා. හරි. මේකේ තියෙන්නේ මෙතන region එකක් bipolar transistor. හරි. ඒකේ අපි JFT discuss කරනකොට කරමු මේ JFT වල තියෙන්නේ එහෙම එකක්. එතකොට මෙතන තියෙන්නේ මෙහෙම පොඩි layer. right? එතන ඊළඟට රෝලෙන් යන්න the semiconductor region emits carriers in it the base region in the middle is a very thin layer of semiconductor semiconductor and semiconductor and it has been doped doped with very low doping level with very low doping level. Since the base is very thin, charge carriers can easily flow across it across it, but as its doping level is very low. Doping level is very low. It weakens that flow. This will lead to control the flow of current. The collector doped with moderate level and the area is large. Okay. දැන් අපි NPN transistor එකක් ගත්තොත් එන්නේ NPN transistor එකක මේ මොනවාද වැඩිපුරම free electrons වැඩි. NPN transistor එකක free electrons වැඩි emitter එකේ ඊට පස්සේ collector එකේ ඊට පස්සේ මේකේ holes වැඩියෙන් තියෙන්නේ මේ මොකක්ද basic right ඒකේ තියන්න පොඩි number 1 කියලා දාලා NPN transistor කියලා දාලා පොඩි topic එකක්. The majority carriers of an NPN transistor is free electrons මේකත් කට් කරලා දාගෙන base වැඩිපුරම තියෙන්නේ emitter. පොඩි වෙලාවට දාන්න. එතකොට මේකේ මේ free electrons වැඩි majority carriers higher. ඊට පස්සේ මේ low concentration free electrons, base low concentration of force. Right? They in PNP transistor, the majority carriers are holes. The mobility of free electrons is higher than to the mobility of free electrons is higher than to the free electrons is higher than to the mobility of holes. Therefore we are considering only NPN transistors. Okay. Write down another topic. Free region of transistors. Right. That means, so when we are using the transistor as the what is the use of the transistor? අපි මොකද transistor එක use කරන්න තියෙන්නේ? Signal amplification එක කරන්න. We have to amplify the signal, right? To amplify the signal, we are using the transistor. So that when we input the signal to the transistor, we have to first of all the transistor in the active region. So we have to activate the transistor. එතකොට අපි transistor එකක් activate කරනවා කියලා කියන්නේ මේ අපිට කරන්න කියන්නේ අපි මොකක් හරි machine එකකින් වැඩක් කරන්න කලින් අපි machine එක start කරනවානේ. දැන් machine එක තියලා අපි වැඩේ කරගන්න බෑනේ. start කරනවානේ. transistor එකත් start කරන්න ඕනේ. දැන් අපි transistor එකත් මේක පාවිච්චි කරනවානේ start කරන්න ඕනේ. First of all, we have to find out how to start the transistor in the active region. So there are three regions. So first region is we ඉස්සරහට කතා කරනවා cutoff region. So in the cutoff region, that is mean the transistor is not working, right? So the active region. So that word also gave the idea. Word active වෙලා තියෙන එක. ඒතකොට අපි මේක use කරන්නේ active region එක. ඊළඟට තුන්වෙනි එක තමයි saturation region. So in the saturation region, we are using it is in the saturation. But saturation කියලා කියන්නේ අපි මේ use කරන මේ transistor එකේ all the majority carriers are coming to the action, and there is no another the all the majority carriers are coming to the action. So there is not extra one. Therefore, it saturates. So make up is discuss right. So these are the regions, three regions. So we have to identify how to get the active region. So in the active region, only the active region, the transistor will start. Okay, right. Write down the number one, cutoff region, active region, and saturation region. Okay, then write down bias in the transistor topic here. Bias in the transistor to the active region. To the active region. Okay, so we have to bias the transistor. So how can we bias the transistor? For this case, we have to get the transistor and supply some voltage. So we are mainly discussing the NPN transistor. අපි ගොඩක් use කරන NPN transistors. එතකොට NPN transistor එක අපේ තියෙන මේ usage එක තමයි we are using to amplify the signal, right? So this is base, this is emitter, this is collector. So we need to bias this one. So we know there is a PN junction. We have to forward bias. BE should be forward bias. BE junction forward bias. So how can we forward bias this one? So we need to use some kind of voltage. This voltage we know we are calling VPB, supply of the base, right? And we are using another type of voltage source that called VCC to reverse bias the BC reverse bias, B and C reverse bias. So we have to first of all use this method, use the voltage and forward bias the BE junction, the reverse bias the BS, that BE junction, and reverse bias the BC junction, right? Then we can go to the active region, right? So when we are using this transistor, we are taking some the current, right? So this current called IC current, and this is called IB current, the current of the base. Then this one is IE current. So IE current contains the IC plus IB, right? So these are the representation, right? Okay. Write down the main the one of major application of transistor. The one of major application of transistor. One of major application of transistor is as a signal amplifier. In this case, the transistor must always be kept in operating region, active region for this the transistor must bias using an external voltage source as follow. So write down number 1. BE junction number 1, BE junction should be forward biased BE junction should be forward biased. Number 2, BC junction should be reverse biased. Okay. Then write down the subtopic. Make a action of the NPN junction. Okay. Action of NPN junction. Draw this one. Okay, write down. When given the higher potential to E, higher potential to B, higher potential to B than E, the BE junction is forward biased. Even higher potential given to E given to C than to capital B, the BC junction is reverse biased. Very reverse biased. Therefore, the transistor inactive region. Inactive region. So, right. So we are using a higher potential to C and lower potential to B. I will take as the example 2 volts and 6 volt. එතකොට මෙතන එන්නේ +6 මෙතන එන්නේ +2 right? So this is earth, this is should be 0. Therefore this junction, this PN junction, so this is P and this is N, so this is this having the highest potential, so this is having the lowest potential, therefore this is in reverse bias. Reverse bias වලදී තේරෙනවද? Right. ඒකත් ඕන දාගන්න example එක. Right. මෙතන example එක. Right. ඒක මාක් කරගන්න එක. Okay, write down. Since the BE junction, write down. Since the BE junction is forward biased, the maturity carriers in the N region, will move to the P site, to the P region. The electric current corresponding to the electric current corresponding to the electrons is called IE emitter current. That means what? So when this forward bias, so the current is traveling to this direction, right? Then write down. So to every NPN and PNP transistors, PNP transistors, IE equals IC plus IB. Right? That means, but the IC කියලා current එක ගොඩක් වැඩි. IC is greater than to the IB. මෙතන තියෙන current එක අඩුයි. So because of that, IE approximately equals to the IC. Right? මෙන්න මේක හැම වෙලාවම අපි use කරන එක. ඒකට ඔන්නම වෙනවා. Right? As an example, this is like a IB like a 1. IB is a 1. IC is the 99. So IE is the 100. Yeah. Right? Then following parameters I used to explain the action of the transistor. Right. අපිට දැන් okay parameters කියන දැනගන්න ඕනේ. Right. මේකදී මම IE IB IC දන්නවනේ. transistor. So this is base, this is collector, this is emitter. So this voltage is VCE. This voltage is VBE. Most of the case we are using VC and VBE, right? And also this one is VCB or VBC, right? So we are using these symbols, and also this is IC current, IB current, so IE current, right? මේකෙදි මේ IB කියලා කියන්නේ පොඩි කරන්ට් එකක්. මෙයාට relatively මෙතනින් කරන්ට් එකක් එනකොට මෙතනදී අර majority carriers minority carriers කියලා තියෙනවානේ. එතකොට ඒ කරන්ට් එකකින් IC කියලා කියන කරන්ට් එක වෝල්ටේජ් සප්ලයි එකෙන් දෙනකොට මෙතනින් ලොකු කරන්ට් එකක් එනවා. එතකොට මේ එන කරන්ට් එකයි මේකයි එකතු වෙලා තමයි මෙතනින් යන්නේ. හරිද? මේ දෙන්නගේ ගත්තොත් එහෙනම් මේ the IB is the lowest current, right? So then when we discuss the IE, so these are the parameters. What is the mean by the VCE? VCE කියලා කියන්නේ voltage of the collector relative to the emitter, right? ඊට පස්සේ ඔන්න ඔය විදිහට තමයි කියන්නේ, right? VE VC, and also we are using the VC, voltage of the potential of collector. VB, potential of base. VE, potential of emitter. අර පැරාමීටර්ස් අයිඩෙන්ටිෆයි කරගන්න ඕනේ, right? Okay, මේක කට් කරලා දාගන්න. Potential given potential of the collector relative to the base. And also in this case VCC, මෙතන තිබ්බ VCC කියලා කියනවා ගත්තා. External voltage supply to the collector. VDB, external voltage supply to the base. Right? Very good. Very good parameters. Basic parameters. ආයෙ මේකේ මේ අපි use කරන පොඩි equation එකක් තියෙනවා VCE කියලා කියන්නේ. So what is the VCE? VCB plus VBE, right? So this is the kind of the potential of the collector relative to the emitter is equals to the potential of the collector relative to the base plus potential of the base relative to the emitter, right? So we are using that equation also, right? Okay. Then write down the subtopic. Then make up මරලාට මෙතන තියෙන මෙතන identification එක හරියට කොහොමද වෙන්නේ කියලා අපි කතා කරන්නේ නෑ. අපි මේ කතා කරේ තාම terms. ඊට පස්සේ තමයි අපි යන්නේ active region එකට කොහොමද එන්නේ, saturation region එකට කොහොමද එන්නේ, cut off region එක කොයි විදිහටද තියෙන්නේ ඒක discuss කරන්න, right? ඊළඟට ලියන්න configurations of subtopic එක configuration of transistor. Configuration of transistor. Okay, so mainly we are using the transistor to amplify. So in amplifier, so there is a transistor. So we have to input, then we have to get the output, right? So when we input the amplifier, so the output coming to the in outside. So in the amplifier there is a arrangement. So there is a I told there is a three terminals. මේ terminals වල අපිට දාන්න පුළුවන් arrangement තියෙනවා කීපයක්. එතකොට base, collector, emitter. Right? මේක arrange කරන්න පුළුවන් විදි තියෙනවා ටික. හරිද? විදි තියෙනවා තුනක්. Right? So we can arrange the common branch as the emitter. We can arrange the common branch as the base. We can arrange the common branch as the collector. එතකොට configurations තියෙනවා තුනක්. Right? We need to identify what are the key configurations. Okay? So when I take the common base configuration, अभी ये तुरंत डिस्कस करें हमको एक रानी ध्यान रखो इधर इनका तो राइट एक ध्यान ला there are three ways or configurations that a transistor can be connected to the electronic circuit. The transistor has only three terminals. The transistor only has only three terminals: E, C, and B. Emitter, collector, base. When using it as collector base, when using it as amplifier, it requires two terminals to input signal input the signal, and the two terminals to get output. Therefore, one terminal has to be 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 used in common. Right. මෙන්න මේක දාගන්න. ඉන්පුට් එක දානකොට ඇම්ප්ලිෆයර් එකක් පස්සෙන් අවුට්පුට් එක එනවා. අපි දැන් මේකෙදි මේ ටී කන්ෆිගරේෂන්ස් වලට ඔන්න ඔය ඩයග්‍රෑම් එක තමයි අඳින්නේ. හරි. මෙන්න මේක දාගන්න. right. okay. දැන් අපි මේ configurations තුනක් තියෙනවා නම් when we take in the three configurations, we need to identify what is the best one. So how can we find what is the best configuration? අපි configurations තුනක් තියෙනවා කියලා කියනවා, common base, common emitter, common collector. So we need to identify what is the best one, right? So how can we identify using the input and output? How can we identify what is the best one? අපි කොහොමද හොයාගන්නේ මොකක්ද හොඳම කියලා? output එක හොඳ වුණොත් මේක ගන්න පුළුවන් අපිට. එහෙනම් when we are choosing the some configuration, we need to identify what is the output, what is the higher output. When we input some signal, what is the highest output of that signal? So we need to identify what is the highest one. So for that case, we are using current gain, some parameters. current gain කියලා කියන්නේ I out එක I input එක වගේ කොච්චරද, right? Then voltage gain, so V out V in, what is the ratio between? Then power gain, P out, but rather than be P in. So we need to find out these three parameters. If some configuration has the best current gain, best voltage gain, and the best power gain, that configuration need to be identified. Then we have to use that configuration. ඒ කියන්නේ අපි ඒ configuration එක use කරලා තමයි input එක output එකක් වෙලා හොඳට ලොකුට එන්නේ. right? නැත්නම් අපිට ඒක වැඩක් නැහැ. අනිත් තව තුනක් තියෙනවා. ඒ තුනෙන් එකක් අපි select කරගන්න ඕනේ. But what is the best configuration, right? Okay. Write down to select configuration. Best configuration. Three parameters are used. To compare. Okay. They are current gain, voltage gain, and power gain. Okay. Write down this. Okay. Then we have to discuss what are the pre-configuration and what are the best configuration, right? We have to choose what is the best configuration, right? Okay. So I will compare these three configurations. Are මම මේ configurations තුන compare කරනවා. Pre-configuration. common base, common emitter, common collector, right? We need to identify what are the gains of this configuration, right? So for this case, current gain. අර idea එක තියාගන්න මේ normally IB කියලා කියන්නේ 1 වගේ IE කියලා කියන්නේ IC කියලා කියන්නේ 99 වගේ this is as 100, right? එහෙම idea එකක් තියාගන්න ඕනේ. What is the current gain? Output I out I in. So what is the I out? එළියට එන එක නෙමෙයි මෙතන තියෙන current එක මොකක්ද? IC. මෙතන තියෙන IC, right? I out කියලා කියන්නේ IC. එළියට තියෙන ඇතුළට එන current එක කියලා කිව්වට මෙතන එළිය පැත්තේ තියෙන current එක. අපි මේකෙදි කරන්නේ මොකද්ද? We are using it as the amplifier. Output is this one, input is this one, not the current, right? The current of the outside one is the IC, right? So IC over IE, it has 99 over 100, 0.99, right? So we are taking it as alpha is 0.99, right? So the current gain of this one, current gain එක මෙයා ගත්තොත් එහෙම I out I in. So what is the I out? I out mean IC. The I in is IB. So I will take it beta. Beta equals to IC. IC mean 99. This is 1. So this is 99, right? So alpha is 0.99, beta is 99. This is good, right? So when we move to this one, current gain, I out, I in, I out. Out එක මොකද්ද? IB. Input IB. So the IE equals to 100. This is equal to 1. That is mean 100. So I will take as 0. This is also good, but this is also good, but this is not good, right? We can neglect this one. Then we have to select each case. So when we compare in each case, the voltage output is higher than this one, right? And the power output is higher than this one. Therefore, we are using the common emitter configuration, right? Okay. Do this one. Considering three configuration, the gains, the gains can be taken as follows. be taken as follow. So we can take the gains. So first gain is the this configuration, common base, common emitter, common collector. So current gain, voltage gain, power gain. Okay, we can identify these three parameters. So, but we have the idea about the what are the voltage gain and power gain. අපි ඉස්සරහට කතා කරන එකේදී ඔයාලට තේරෙයි මේ මොකද්ද මේ voltage gain එක power gain එක කියලා කියන්නේ කියලා. ඕකේ සාමාන්‍යයෙන් අපි ගත්තොත් එහෙම the current gain of the common base less than 1 less than 1. This is 99 වගේ. higher. Voltage gain එකේදී lower, this is very high. Less than 1. Power gain එක ගත්තොත් එහෙම the මෙතන තියෙන power gain එක low. මේක ඇවිල්ලා higher value. Is there in middle range? Right. Then මෙහෙම තියනවා නම් මේක හොඳම power. What is the best one? Common emitter. So we need to find out what is the best. So this one is the best configuration. So therefore, in every case, we are using the common emitter configuration, right? Okay, do this table also. එතකොට එතන in amplifier circuits the common emitter configuration in amplifier circuit the common emitter configuration of transistor is widely used. The main reason for this it gives both higher current gain and higher voltage gain compared compared to other configuration. Compared to other configuration. Compared to other configuration. Okay. Other configuration, right? Okay. Write down the topic. Characteristic curves. Characteristic curves. Topic is the characteristic curves. Characteristic curves of common emitter configuration. Of common emitter configuration. Okay. In this case, we need to find what is the characteristic curves, right? There are three characteristic curves, right? Number one is the input characteristics. So input characteristics, we are discussing what are the input variations. So input variation means, so if we clearly see the input of the common emitter configuration, what are the input? Make a base එක, make an emitter එක, make a collector එක, make a current එකක්, මෙතන යන්නේ IE, so IB. So what are the input parameters? Input parameters. So we are input. Input mean this one. We are input. Then we get the output. In this case, output. So input means we are inputting, right? Input. So what is the input? So the input is IB, and also voltage is VBE. So the variation of input characteristic means variation of VBE versus IB. Right? VBE, IB, right? So the other one is, the second one is transfer characteristics. Transfer characteristics. So transfer characteristic. This is the variation of variation of IB and IC. IB and IC can transfer with IB kai IC kai. Right? IB versus IC. Right? So then we are getting the output characteristics. Variation of Elliott method VCE versus IC. So we need to identify these three characteristics. That means we need to get the three type of curves of these characteristics, right? So then after this we need to identify what are the curves corresponding to the this, right? Okay, write down. To understand the operation of a transistor, the relationship among VBE VCE, 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 VCE. IB and IC should be considered. IB and IC should be considered. IB and IC should be considered. The curves which represent this relationship, the curves which represent this relationship graphically are called the characteristic curve. These curves are presented. These curves are presented in three major forms. As follows. Right. Write down number one. As follows. Write down number one. Input characteristics, variation of this IBM. This one. Output characteristics, the transfer characteristics, and we have to study separately. Right? Okay, write down this one. Input, transfer, output characteristics.